topic number 4, chemical thermodynamics. From that we are seeing entropy, that is another property. Now the measurement of disorder of molecules in a substance is called an entropy. Now see the first. Now you know that solid on heating converted into the liquid, on heating liquid again converted into the gases, and when we are taking out the heat, gas again converted into liquid, liquid converted into the solid. Now see in the solid state, the all particles are closely packed. So here disorder or randomness is very less. So in this case entropy is very less. But when solid turn into the liquid, the molecules are away from each other. So the randomness or disorder increases. So entropy also increases. In the gaseous state, the molecules are moving in any direction with random motion. So the entropy increases because the disorder increases. So in gaseous state, entropy is more, but in solid state, it is very less. So entropy is a state function, depend upon the initial state and the final state. So we have to calculate the change in entropy. So entropy change of the system is equal to the amount of heat transferred to it in the reversible manner and divided by temperature T in the Kelvin. So delta S equal to heat transfer during reversible process divided by temperature. From this equation we know that entropy and temperature are opposite to each other. As the temperature increases, entropy decreases, or vice versa. Now depending upon the entropy, that second law of thermodynamics related with the entropy. Now second law of thermodynamics states that entropy of the system and its surroundings increases in a spontaneous process. A spontaneous process means what? The process carried out by itself. For example, heat flows from hot body to the cold body, or water flows from higher level to the lower level. Now these are the spontaneous processes. So second law states that entropy of system and its surrounding increases in a spontaneous process. Now see that delta S total is equal to delta S of system plus delta S of surrounding. So delta S of system plus delta S surrounding heat transferred. So QR divided by T. So it is also equal to delta S minus delta H upon T. Now depending upon the change in entropy, the process is spontaneous, non-spontaneous, or in equilibrium, we can find out. Now see the first condition. If delta S greater than 0, the process is spontaneous. If delta S less than 0, the process is non-spontaneous. And third, if delta S equal to 0, the process is in equilibrium. Now by using the value or the magnitude of delta S, we can understand the given process is whether spontaneous, non-spontaneous, or in equilibrium. Another new property, that is Gibbs energy. The new thermodynamic property which explains the spontaneity of the reaction or the system, introduced by the American theoretician J.W. Gibbs, is called the Gibbs energy G. So G equal to H minus Ts. Now equation number 1, where H is enthalpy of system, T temperature, and S entropy of system. But Gibbs energy is a state function, depend upon the initial state and the final state. Hence change in Gibbs energy calculated at constant temperature. Now see equation 1 become delta G equal to delta H minus T delta S. But previously we have seen that total entropy of the system given by delta S total equal to delta S system plus delta S surrounding. This equation also becomes delta S total equal to delta S system minus delta S upon T. Now we have seen previously. So by multiplying by T to the total equation, T delta S total equal to T delta S system minus delta S. Now by changing the signs of all three terms, so minus T delta S total equal to minus T delta S system plus delta H. Now we will rearrange that equation. So minus T delta S total equal to delta H minus T delta S. Now see the equation number 2 and equation number 3. So by comparing both, so right sides are same. So left side become the equal. So delta G equal to minus T delta S total. Now equation number 4. So equation 4 shows that Gibbs energy and entropy are opposites to each other, which is indicated by the negative sign. So previously whatever we have seen, that is delta S greater than 0, this process is spontaneous. Now it changed. So when delta G less than 0, then process is spontaneous. Second part, if delta S less than 0, now it becomes delta G greater than 0, the process is non-spontaneous. And if delta S equal to 0 and delta G equal to 0, then process is in equilibrium. See relation between the Gibbs energy and equilibrium constant K. Now the equation is already given that delta G equal to delta G 0 plus RT ln Q. Now see the one by one terms. Delta G 0 is equal to change in standard Gibbs energy. R, that is a gas constant, T is a temperature, and Q is a quotient. If the reactions are, the reactants and the products are in the liquid state or in the gas state, so depending upon the phase of the reactant and the product, we can find out the value of Q. Now consider a reaction, that is all reactants and products are in the liquid state. So A, small a capital A in the liquid state plus B small l, that is in the liquid state, equal to C Cl plus D Dl. Now equilibrium constant Kc according to the law of mass of action. The concentration of product divided by product of concentration of reactant raised by their coefficients. Now we will get the value of Kc, and if in the reaction the reactants and products are in the gas state, we have to calculate equilibrium constant as a Kp. Now all are in the gas state, so they are exerting the pressure. So instead of concentration, we have to consider the pressure of reactant and the product. So at equilibrium, delta G equal to 0, and that Q becomes Kc or Q becomes Kp. So by adding the value of this delta G and Q in equation 1, so we are getting equation 1, 0 equal to delta G 0 plus RT ln Kc. So rearranging equation, we are getting delta G 0 equal to minus RT ln Kc. So instead of Kc, we can also add the Kp for gaseous reactant products. Now ln means what? It is a log to the base. So E, it converted into the log to the base 10. So by multiplying 2.303. So equation becomes delta G0 equal to minus 2.303 RT log of 10 Kc, or delta G0 is equal to minus 2.303 RT log of 10 Kp. So from this topic we have seen videos. Now you have to study in a proper way to find questions which are related to these points. So thank you very much for watching this video.